Okay. So whether the PDF is visible now? So just wait a minute. Now I'll just display the PDF. Okay. So now the PDF is visible.
Yes, sir. PDF is visible.
Yes, sir.
Okay. Okay, so in the last class, we're discussing about the what are the three different configuration of them. So I'll just brush up the topic in the previous class, and because this is an important topic, so because based upon this only, we're going to move further in this when we're going to see the different configuration. So in the previous class, I was discussing about the MOSFET and what are the three basic configurations of the MOSFET. So in this three configuration, one is the common source and a common gate, as well as a common, third one is a common drain. So by the name it is called as a common source because one of the terminal, the source will be connected to ground, so it is also called as a grounded source configuration. So wherein which you are going to apply the input voltage to the gate and source. So since the source is being common, so gate and source we are going to apply the input, and across the drain and source we are going to connect the drain resistance, wherein which you are going to get the output. So this is the quite common which we have seen in the previous analysis as well. So when we are discussing about the small signal amplifier, so we have taken this common source configuration itself, and it is widely used. So because it is because of the high gain, so among the other different configurations, so you're going to get the maximum gain in this common source. So because of which you're going to this common source configuration is widely used in the available, and it is having a wide application. So source will be common, and the gate will be applying input, and as usual the drain. So you're going to get the output. So anything. So in a MOSFET, so output terminal will be considered as a drain terminal, and input terminal will be considered as a gate, and the source is also considered as a gate, and source will be considered as a input terminal. And in the second configuration, in the common gate configuration, we are going to see the gate will be common between the input and output. So as usual, so the drain will be considered as the output because since the gate is connected to ground and the drain is available, so we are going to apply the input across the source, and we are going to get the output across the drain. So because of which you are going to call this as a common gate configuration. And the third configuration which you are going to study is nothing but common drain configuration. In this common drain configuration, so drain terminal will be connected to ground. So drain terminal will be common between the input and the output. So since the output terminal, which will be considered as a drain terminal itself, we have connected to as a common. So that means we have shorted to ground main. So you have to think that so the input will be given at the gate, and the output we are going to connecting across the load resistance. So this load resistance is nothing but the output where we are going to connect across the source terminal. So because of which you are going to see that the source, whatever the output voltage which you are going to get, so this output voltage is going to follow the input voltage with a minus small difference. So it is called as also called as a source follower. So common drain, or it is also called as a source follower. So these two configurations we are going to study in for the discrete circuit. So and also we have seen that when we are going to see the analysis. So here we are going to do the analysis only for the discrete circuit. So the performance parameters of the amplifier will be taken care only for the discrete MOSFET amplifier, and the three different configurations are also consider the analysis for the discrete circuit itself. So whereas in the further, so the same type IC MOSFET amplifiers also there. So wherein which all the passive components will be not there. So only the active components we are going to design the amplifier for the common source, a common gate, as well as a common drain configuration. So there, if you consider the characteristics of the IC MOSFET, whatever the different configuration will be not same exactly as that of a discrete circuit, because we know that in the discrete circuit, so there are so many losses are involved, and there are because of the passive components which are going to be involved in this. So because of that, so the characteristics will be not the same as that of in the IC MOSFET. So in this we are going to, in this chapter, so we are going to deal only with respect to discrete circuit. So discrete circuit antidange you should consider that so when you have done the AEC lab, so that is the ED lab. So what you have done, so in there in the breadboard, so in that breadboard, so all the components as well as transistors and all you are going to insert, and you are going to see the output voltage, right? So that is what the discrete circuit component. So all active component will be there, passive components will be there, and there are connecting wire also it will be there. So all these losses connecting wires and also it is going to deviate the characteristics from that of IC MOSFET amplifier configuration. So these are the three basic configurations we have studied in the previous class, and also we have seen what are the characteristics which are very important for considering for an amplifier. So whatever the configuration we are going to see for that configuration, so we are going to analyze the performance of an amplifier. So for an analyzing of any performance of an amplifier, so we are going to consider, so amplifier means, so what should be the input resistance, what should be the output resistance, sorry. So what should be the input resistance, what should be the output resistance, what should be the gain. So these are the three important parameters. So for any amplifier, so you have to recall about the operational amplifier. So operational amplifier only, what are the ideal characteristics of an operational amplifier. So that is for an ideal characteristics for an operational amplifier, the same characteristics you should have for any type of amplifier, whether you are going to use a BJT or a MOSFET as an amplifier. So amplifier should have the same characteristics like that in the operational amplifier. So operational amplifier is not a different one. So inside the operational amplifier you can see the same BJT or the same FET will be there. So the same thing, so differential amplifier. So at the input stage, the differential amplifier stage will be there. So differential amplifier means, so input will be given to the MOSFET or the BJT itself. So the characteristics is going to remain same as that for the operational amplifier, or it is a BJT amplifier or a MOSFET amplifier. So we are going to see what are the important parameters or the characterizing for the performance of an amplifier. So we are going to consider. So in that case, one is the input resistance. What should be the input resistance? What should be the output resistance? What should be the gain? So in that gain also they have three categories which you have studied over here in the previous day class. So this is a general block diagram of an amplifier. So in which one of the terminal will be common. So that's the reason we have written one terminal connected to ground, and another terminal will be given as the input. So another terminal will be connected as the output. So one of the load resistance which will be considered as the succeeding stage amplifier stage can be considered as a load, or else we can have an actual load being connected across the output of a current amplifier. So if you are going to study the current amplifier, so this can be actual load which can be having the actual load being connected across the output terminal, or this can be considered as an input resistance of the succeeding amplifier stage. So succeeding amplifier stage in the input resistance can be considered as a load resistance for this amplifier when you are going to study. The same way, so the signal source. So when you are going to have a signal source, because we are going to consider as an amplifier means, for this amplifier means, well, there should be some signal source. So here for this MOSFET we are going to consider a voltage signal source. So voltage source we are going to connect. So this is nothing but a signal, small signal voltage source. For the every voltage source there will be associated with a small signal resistance associated with that. So because of which what we are going to call, so this hello.
Sir, ಇದು ನೋಟ್ ಪ್ಯಾಡ್ ಯೂಸ್ ಮಾಡ್ತೀರಾ ಸರ್?
ಮೇಡಮ್ ನಾನು ನೋಟ್ ಪ್ಯಾಡು ಆ್ಯಕ್ಚುಲಿ ಯೂಸ್ ಮಾಡ್ತಾ ಇಲ್ಲ, ಯಾಕಂದರೆ ಐ ಆಮ್ ನಾಟ್ ಕಂಫರ್ಟಬಲ್, ನನಗೆ ಆಗಿಲ್ಲ. ಸೊ ಐ ಆಮ್ ಪ್ರಾಕ್ಟೀಸಿಂಗ್ ಆ್ಯಸ್ ವೆಲ್ ಆಸ್ ಮೈ ಲ್ಯಾಪ್ಟಾಪ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಸಪೋರ್ಟಿಂಗ್. ಸೊ ಈವನ್ ಐ ಹ್ಯಾವ್ ವಾಟ್ ದ ನೋಟ್ ಪ್ಯಾಡ್, ಬಟ್ ನೋಟ್ ಪ್ಯಾಡ್ ನನಗೆ ವರ್ಕ್ ಮಾಡೋಕ್ಕಾಗ್ತಾಯಿಲ್ಲ. ಸಿಸ್ಟಮ್ ಸಾಫ್ಟ್ವೇರ್ ಇದೆ ಅಲ್ವಾ, ಹಾರ್ಡ್ವೇರ್ ಡ್ರೈವರ್ಸ್ ಇನ್ಸ್ಟಾಲ್ ಆಗ್ತಾಯಿಲ್ಲ ನಮ್ಮಲ್ಲಿ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಅದನ್ನು ಇನ್ನೂ ಕಂಪ್ಯಾಟಬಲ್ ಆಗಿಲ್ಲ ಅದು. ಸೊ ಐ ಆಮ್ ಸ್ಟಿಲ್ ವರ್ಕಿಂಗ್ ಆನ್ ದ್ಯಾಟ್. ಸೊ 2 times ಡ್ರೈವರ್ಸ್ ಇನ್ಸ್ಟಾಲ್ ಮಾಡೋಕ್ಕೆ ನೋಡಿದೆ. Even I have brought that notepad. So if notepad was there, then I should have written and I would have explained it better way. So but thing is that it is drivers are not installing.
ಸರ್, ಇಫ್ ನಾಟ್ ನೋಟ್ ಪ್ಯಾಡ್ ನೀವು ಒಂದು ಶೀಟ್ ಅನ್ನು ಕೆಲವು ಸರ್ಕ್ಯೂಟ್ಗಳನ್ನ ಬರೆದು ತೋರಿಸಿದ್ರೆ ಆಗತ್ತಲ್ಲ ಸರ್?
ಇವಾಗ ನಿಮಗೆ ಯಾವ ಥರ ಕನ್ಫ್ಯೂಷನ್, ಏನಾರೇ ಎಕ್ಸಾಂಪಲ್ಲು ನಿಮಗೆ ಏನಾದ್ರು ತೊಂದರೆ ಆಗ್ತಿದೆಯಾ ಫಸ್ಟ್ ಮಾಡ್ಯೂಲಲ್ಲಿ? ಸಿ ದಿಸ್ ಈಸ್ ನಾನು ಸೆಕೆಂಡ್ ಮಾಡ್ಯೂಲಿಗೆ ಹೋಗ್ತಾ ಇದ್ದೀನಿ ಅಂತಲ್ಲ. ಸೊ ಫಸ್ಟ್ ಮಾಡ್ಯೂಲಲ್ಲಿ ಏನಾರೇ ಡೌಟ್ಸ್ ಬಂದಿದೆಯಾ? ಇಫ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಎನಿ ಡೌಟ್ಸ್ ದ ವೇ ವಿ ಆರ್ ಗೋಯಿಂಗ್, ಸೊ ಇಫ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಎನಿ ಡೌಟ್ಸ್ ಯು ಕ್ಯಾನ್ ಡಿಸ್ಕಸ್ ನೌ ಇಟ್.
ಸರ್, ಆ ನ್ಯೂಮರಿಕಲ್ ಸಮ್ಸ್ ಎಲ್ಲ ಮಾಡಿದ್ರಲ್ಲ, ಅದ್ರಲ್ಲಿ ಸರ್ಕ್ಯೂಟ್ ಎಲ್ಲ ಹಾಕಬೇಕಿತ್ತಲ್ಲ.
ಓಕೆ.
ಅಂಥದನ್ನೆಲ್ಲ ನೀವು ಒಂದು ಶೀಟ್ ಅಲ್ಲಿ ಮಾಡಿಬಿಟ್ಟು ತೋರಿಸಿದ್ರೆ ನಮಗೂ ಇನ್ನೂ ಚಂದವಾಗಿ ಅರ್ಥ ಆಗತ್ತೆ.
ಓಕೆ ಸರಿ. ನ್ಯೂಮರಿಕಲ್ಸನ್ನ ಹೆಂಗೆ ಮಾಡಿದ್ದೀನಿ ಅಂತನಾ? ಸೊ
ಆಮೇಲೆ ಇನ್ನು ಮಿಕ್ಕಿದ ಇಂಪಾರ್ಟೆಂಟ್ ಸರ್ಕ್ಯೂಟ್ಗಳು ಯಾವ್ದೆಲ್ಲ ಇದೆಯಲ್ಲ ಸರ್, ಎಕ್ಸಾಮ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ಆಗಲಿ ಇಲ್ಲ, ಈ ಇಂಪಾರ್ಟೆಂಟ್ ಸರ್ಕ್ಯೂಟ್ಸ್ನ ನೀವು ಒಂದ್ಸಲಿ ಒಂದು ಶೀಟಲ್ಲಿ ಮಾಡಿಬಿಟ್ಟು ತೋರಿಸಿದ್ರೆ ನಮಗೂ ಇನ್ನೂ ಅರ್ಥ ಆಗತ್ತೆ ಅಂತ.
ಓಕೆ, ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳು ಸಾಲ್ವ್ ಮಾಡಿಬಿಟ್ಟು ಪೇಪರಲ್ಲಿ ನಾನು ಅಟ್ಲೀಸ್ಟ್ ಒಂದ್ಸರಿ ಸಾಲ್ವ್ ಮಾಡಿಬಿಟ್ಟು ನಿಮಗೆ ತೋರಿಸಿದ್ರೆ, ಸೊ ಯು ವಿಲ್ ಬಿಕಮ್ ಟು ನೋ. ಸೊ ಇದು ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಡಿಸ್ಪ್ಲೇಯಿಂಗ್ ಇನ್ PDF, ಸೊ ಐ ಶುಡ್. ಓಕೆ. ಓಕೆ ದಟ್ ಐ ವಿಲ್ ಬಿ ಡೂಯಿಂಗ್. ಸೊ ಇವತ್ತು ನಾಳೆ ಬೆಳಗ್ಗೆ ಅಷ್ಟೊತ್ತಿಗೆ ನಾನು ನಿಮಗೆ ಮಾಡ್ತೀನಿ. ಸೊ ಐ ವಿಲ್ ಜಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಬಿಕಾಸ್ ಈವನ್ ಐ ಆಲ್ಸೋ ಫೇಸ್ಡ್. ಸೊ ಯು ವಿಲ್ ಬಿ ಲಿಸ್ನಿಂಗ್ ಲೈಕ್ ದಿಸ್ ಓನ್ಲಿ. ಸೊ ಇಫ್ ಐ ಟೆಲ್ ಒನ್ ಸ್ಟೇಜ್ ಬೈ ಒನ್ ಸ್ಟೇಜು ಸೊ ಅರ್ಥ ಆಗಲ್ಲ. ಸೊ ದಟ್ ಟೂ ನ್ಯೂಮರಿಕಲ್ಸ್ ವಿಚ್ ಈಸ್ ಎಕ್ಸಾಮ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಸಮ್ ನ್ಯೂಮರಿಕಲ್ಸ್ ಐ ವಿಲ್ ರೈಟ್ ಆ್ಯಂಡ್ ಐ ವಿಲ್ ಡಿಸ್ಪ್ಲೇ, ಐ ವಿಲ್ ಶೇರ್ ದಟ್. ಓಕೆ. ಸೊ ಇವಾಗ ಫಸ್ಟ್ ಮಾಡ್ಯೂಲಲ್ಲಿ ಏನಾರೇ ಕನ್ಫ್ಯೂಷನ್, ಅರ್ಥ ಆಗಿಲ್ಲ ಏನಾರು ಟಾಪಿಕ್ಸ್ ಏನಾರು ಇದ್ದರೆ ಸೊ ಯು ಕ್ಯಾನ್ ask her. Because module 2 I am going to start means module 1 if there should be no doubts and all. So module 1 ಏನು ಡೌಟ್ ಇಲ್ಲ ಅಂತ ಅನ್ಕೊಂತೀನಿ. So anybody in the class? So if you are having any doubt you can ask her. ಮಾತಾಡ್ರಪ್ಪ, ನಿಮಗೆ ಕೇಳ್ತಾ ಇರೋದು. See how they have asked. So ನನ್ನ ಅನದರ್ ಥಿಂಗು, ಹಗ್ಲಗ್ಲ ಕೆಲವರು ಹೊರಗಡೆ ಹೋಗ್ತಾರೆ ಬಿಕಾಸ್ ನೆಟ್ವರ್ಕ್ ಇಶ್ಯೂ ಇರ್ಬೋದು. ಕೆಲವರು ಹುಡುಗರು ಏನೋ ರಿಮೂವ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅಂತ ಏನೋ ಕಂಪ್ಲೇಂಟ್ ಬರ್ತಿದೆ ಫ್ಯಾಕಲ್ಟೀಸಿಂದ. ಸೊ ಕೆಲವು ಫ್ಯಾಕಲ್ಟೀಸ್ಗಳು, ಕೆಲವು ಸ್ಟೂಡೆಂಟ್ಸ್ಗಳು ಇನ್ನೂ ಸ್ಟೂಡೆಂಟ್ಸ್ಗಳಿಗೆ ರಿಮೂವ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅಂತ. ಸೊ ವೈ ಆರ್ ಡೂಯಿಂಗ್ ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ನಾನ್ಸೆನ್ಸ್? ಓಕೆ. ಸೊ ಎನಿಥಿಂಗ್ ನೀಡ್ ಟು ಬಿ ಡಿಸ್ಕಸ್ಡ್ ರೈಟ್ ನೌ or shall I proceed? So numericals, with respect to numericals you want to?
ನ್ಯೂಮರಿಕಲ್ಸ್ ಮತ್ತೆ ಇನ್ನು ಯಾವ್ದಾರ ಇಂಪಾರ್ಟೆಂಟ್ ಸರ್ಕ್ಯೂಟ್ಗಳಿದ್ರೆ ಅದು ನೀವು PDF ತೋರಿಸ್ಕೊಂಡು ಮಾಡೋ ಬದಲು ಒಂದ್ಸಲಿ ಒಂದು ಶೀಟಲ್ಲಿ ಲೈವ್ ಆಗಿ ಮಾಡ್ಬಿಟ್ಟು ತೋರಿಸಿದ್ರೆ ಇನ್ನೂ ಅರ್ಥ ಆಗತ್ತೆ ಅಂತ.
ಲೈವ್ ಆಗಿ ಮಾಡಬೇಕು ಅಂತ. ಸೊ ದಟ್ ನೋಟ್ ಪ್ಯಾಡ್ ನಾನು ಯೂಸ್ ಮಾಡ್ಬೋದು. ನೋಟ್ ಪ್ಯಾಡ್ ಅದು ದಟ್ ಈಸ್ ಸಿಸ್ಟಮ್ ಹಾರ್ಡ್ವೇರ್ ಡ್ರೈವರ್ ಇನ್ಸ್ಟಾಲ್ ಆಗ್ತಾ ಇಲ್ಲ ನಮ್ಮಲ್ಲಿ ಸಿಸ್ಟಮಲ್ಲಿ.
ಇಲ್ಲ ಶೀಟಲ್ಲಿ ಮಾಡ್ಬೋದಲ್ಲ ಸರ್?
ಸೊ ಅದೇ ನಾನು ಮಾಡೋದು ಅಂದರೆ ಇವಾಗ ವೆಬ್ ಕ್ಯಾಮು ಅದೆಲ್ಲ ಸೆಟಪ್ಸು. ಸೊ ಐ ಹ್ಯಾವ್ ಟು ಚೇಂಜ್ ದ ಸೆಟಪ್ಸ್ ಆ್ಯಂಡ್ ಐ ಶುಡ್ ಡೂ ಆ ಥರ ಮಾಡ್ಬೇಕು ಅನಿಸುತ್ತೆ. ಸರಿ, ಐ ವಿಲ್ ಟ್ರೈ ವಿತ್ ದಟ್ ಒನ್. ಸೊ ಇಂಪಾರ್ಟೆಂಟ್ ಸರ್ಕ್ಯೂಟ್ಸು. ಸೊ ಯು ಆರ್ ಫೀಲಿಂಗ್ ಅದೇ ಅದೊಂದು ಡಿಫಿಕಲ್ಟಿನ ಅಥವಾ ನಿಮಗೆ ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ವಾ ಕಾನ್ಸೆಪ್ಟ್ಸು? ಅದ್ರ ಬಗ್ಗೆ ಹೇಳಿ.
ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಆಗ್ತದೆ ಸರ್. ಬರೀ ಇದು ಒಂದು ಸ್ವಲ್ಪ ನ್ಯೂಮರಿಕಲ್ಸ್ ಆಗಲಿ ಅದಾಗಲಿ ನೀವು ಒಂದು ಶೀಟಲ್ಲಿ ಮಾಡ್ಬಿಟ್ಟು ತೋರಿಸಿದ್ರೆ ಅರ್ಥ ಆಗುತ್ತೆ, ಅದು ಇನ್ನೂ ಚೆನ್ನಾಗಿ.
ಓಕೆ 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 ಐ ವಿಲ್ ಜಸ್ಟ್ ಗೋ ಥ್ರೂ ದಟ್. ಸೊ ಥ್ಯಾಂಕ್ ಯು. ಸೊ ಇವಾಗ ಅದನ್ನು ಹೇಳಿರೋದ್ರಿಂದ ನನಗೆ ಗೊತ್ತಾಯಿತು. ಸೊ ಅದರ್ವೈಸ್ ಔಡ್ ಹ್ಯಾವ್ ಆಲ್ಸೋ ಸೊ ಎಲ್ಲ ಅರ್ಥ ಆಗಿದೆ ಅಂದ್ಕೊಂಡು ಹೋಗ್ತಾ ಇದೆ. ಸೊ ಓಕೆ, ಐ ವಿಲ್ ಸಾಲ್ವ್ ದಟ್ ಪ್ರಾಬ್ಲಮ್ ಆಲ್ಸೋ. ಸೊ ಐ ವಿಲ್ ಜಸ್ಟ್ ಸಾಲ್ವ್ ದಟ್ ಪ್ರಾಬ್ಲಮ್ ಆ್ಯಂಡ್ ಐ ವಿಲ್ ಡಿಸ್ಪ್ಲೇ ದಟ್. ಓಕೆನಾ? ಓಕೆ. ಸೊ ಅಪಾರ್ಟ್ ಫ್ರಮ್ ದಟ್, ಸೊ ಅದೊಂದು ನ್ಯೂಮರಿಕಲ್ಸಿಂದ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಇದೆ ತಾನೇ. ಸೊ ದಟ್ ಪ್ರಾಬ್ಲಮ್ ಐ ವಿಲ್ ರೆಕ್ಟಿಫೈ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್. ಓಕೆ. ಸೊ ಅದನ್ನು ಸಾಲ್ವ್ ಮಾಡಿಬಿಟ್ಟು ನಿಮಗೆ ತೋರಿಸ್ಬಿಟ್ಟು ಸೊ ಕ್ವಾಡ್ರಾಟಿಕ್ ಇಕ್ವೇಷನ್ಸ್ ಹೆಂಗೆ ಬರುತ್ತೆ, ಸೊ ಅದೆಲ್ಲ ಟರ್ಮ್ಸು ಐ ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಸೊ ದಟ್ ಒಂದು ನ್ಯೂಮರಿಕಲ್ಸನ್ನು ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಒನ್ ಡೇ ಫುಲ್ ಕಂಪ್ಲೀಟಾಗಿ ಒಂದು 2 ರಿಂದ 3 ನ್ಯೂಮರಿಕಲ್ಸನ್ನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. ಓಕೆನಾ? ಸೊ ಹೌದು
ಥಿಯರಿನೂ ಹಂಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡುತ್ತಲ್ವಾ ಸರ್?
ಹಾಂ ಹೇಳಿ.
ಥಿಯರಿನೂ ಲೈಕ್ ಶೀಟ್ ಆಫ್ ಪೇಪರ್ ಮೇಲೆ ಬರ್ಕೊಂಡು PDF ಡಿಸ್ಪ್ಲೇ ಮಾಡೋದಕ್ಕನ್ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ರೆ ಅರ್ಥ ಆಗುತ್ತೆ ಸರ್.
ಓಕೆ ಓಕೆ. ಸೊ ಇವಾಗ ಕ್ಲಾಸ್ ಅಂದರೆ ಬರೆದುಬಿಟ್ಟು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಲಿ ಅಂತನಾ? ಓಕೆ. ಸೊ
ಅಂದ್ರೆ ನಾವು ಬರ್ಕೋತೀವಿ ಅಂತ ಬೈದ್ರೆ ನಮಗೂ ಅರ್ಥ ಆಗುತ್ತೆ ಅಂತ ಸರ್.
ಓಕೆ ಓಕೆ. ಬಟ್ ಅದೇ ನಾನು ಐ ಆಮ್ ಲುಕಿಂಗ್ ಫಾರ್ ಸೆಟಪ್, ಹೆಂಗೆ ಮಾಡ್ಕೊಬೇಕು ಸೆಟಪ್ ಬರೆಯೋಕ್ಕೆ. ಯಾಕಂದರೆ ಬೇರೆಯವ್ರು ಹೆಂಗೆ ಮಾಡ್ತಾ ಇದ್ದಾರೆ, ಇವಾಗ ನಟರಾಜ್ ಸರ್ ಎಲ್ಲ ಹೆಂಗೆ ಸೆಟಪ್ ಮಾಡ್ಕೊಂಡು ಮಾಡ್ತಿದಾರಾ ಹೆಂಗೆ?
ಸರ್ ನಟರಾಜ್ ಸರ್ ನೋಟ್ ಪ್ಯಾಡ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ.
ಸಿಸ್ಟಮ್ಸ್ ಅಂಡ್
ನೋಟ್ ಪ್ಯಾಡ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ.
ಸಂತೋಷ್ ಸರ್ ಮಾಡ್ತಾರೆ.
ಸಂತೋಷ್ ಸರ್ ಮಾಡ್ತಾರೆ.
ಯಾರು ವೆಬ್ ಕ್ಯಾಮ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಸಂತೋಷ್ ಸರ್? ಓಕೆ ಓಕೆ.
ಎಸ್ ಫಸ್ಟ್ ಇಂದ ಮಾಡ್ತಿದ್ದಾರೆ.
ಹೇಳಿ.
ಮಾಡ್ಯೂಲ್ 1 ನ್ಯೂಮರಿಕಲ್ಸ್ 1 ಮಾಡಿದ್ರೆ ಸಾಕಾಗತ್ತೆ ಸರ್. ಅದು ಒಂದೇ ಇಶ್ಯೂ ಇದೆ ನ್ಯೂಮರಿಕಲ್ಸ್ ಅಷ್ಟೇ. ಇನ್ ಮಿಕ್ಕಿದ ಮಾಡ್ಯೂಲ್ 2 ಮಾಡ್ಯೂಲ್ 3 ಮಾಡ್ಯೂಲ್ 2 ಅಲ್ಲಿ ಯಾರು ಇಂಪಾರ್ಟೆಂಟ್ ಸಬ್ಜೆಕ್ಟ್ ಇದೆ?
ಇಲ್ಲ ಮಾಡ್ಯೂಲ್ 2 ಇಂದ ಇಲ್ಲ ನನಗೆ ಏನೇನು ಇಂಪಾರ್ಟೆಂಟ್ ಅನ್ಸುತ್ತಲ್ಲ, ಸೊ ಐ ವಿಲ್ ಜಸ್ಟ್ ಡೂ ವಿತ್ ದ
ಮ್ಯಾನ್ಯುಯಲ್ ಆಗಿ ಶೀಟ್ ಅಲ್ಲಿ ಮಾಡಿದ್ರೆ ಅದು ನಮ್ಗೆ ಇನ್ನೂ ಚೆನ್ನಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ.
ಸರಿ ಸರಿ ಸರಿ. ಓಕೆ ಓಕೆ.
ಇನ್ ಥಿಯರಿ ಏನೆಲ್ಲ ಇದೆ ಸರ್, ಅದು ಕೆಲವೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ಗಳನ್ನ ನೀವು ಶೀಟ್ ಮೇಲೆ ಬರೆದ್ಬಿಟ್ಟು ಹೇಳಿದ್ರೆ ಅದು ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ಗಳು ನಾವು ಬರ್ಕೊಳ್ಬೋದು ಅವಾಗ.
ಸರಿ ಸರಿ ಸರಿ. ಸೊ ಇಟ್ ಈಸ್ ಗುಡ್. ಸೊ ಈ ಥರ ನನಗೆ ಅಟ್ಲೀಸ್ಟ್ ಒಂದು ಫೀಡ್ಬ್ಯಾಕ್ ಈ ಥರ ಬಂದರೆ ನಾನು ಚೇಂಜ್ ಮಾಡ್ಕೊಬೋದು. ಸೊ ಇಲ್ಲಾಂದರೆ ಹೆಂಗಾದರೆ ಅರ್ಥ ಆಗ್ತಾ ಇದೆ ಅಂತ ಅಂದ್ಕೊಂಡು ಐ ವಿಲ್ ಬಿ ಮೂವಿಂಗ್. ಸೊ ಅದು ಬಿಟ್ಟರೆ ಮತ್ತಿನ್ನೇನೋ ಪ್ರಾಬ್ಲಮ್ ಇದೆಯಾ? ಸೊ ಅಪಾರ್ಟ್ ಫ್ರಮ್ ದಟ್, ಸೊ ನೋಟ್ ಪ್ಯಾಡು ನಾನು ಅದು ಇನ್ಸ್ಟಾಲ್ ಆಗಲಿಲ್ಲ ನನಗೆ. ಸೊ ಡ್ರೈವರ್ಸು ನಮ್ಮದು ವಿಂಡೋಸ್ ಅದು XP ಇದೆ. ಸೊ ಆಪ್ರೇಟಿಂಗ್ ಸಿಸ್ಟಮು ಅದಕ್ಕೆ ಯಾಕೋ ಇನ್ಸ್ಟಾಲ್ ಆಗಲಿಲ್ಲ. ಸೊ ಕಾಲ್ ಯುವರ್ ಕಸ್ಟಮರ್ ಸಪೋರ್ಟ್ ಅಂತ ಬಂತು. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಅದನ್ನು ಈವನ್ ಇನ್ಫ್ಯಾಕ್ಟ್ ಅದನ್ನು ಟ್ರೈ ಮಾಡಿದ್ದೀನಿ. ಗೆಟಿಂಗ್ ಸ್ಟಾರ್ಟೆಡ್ ಅಂತ ಬಂದು ಎಲ್ಲ ಟ್ರೈ ಮಾಡಿದ್ದೀನಿ, ಬಟ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಇನ್ಸ್ಟಾಲ್. ಸೊ ಐ ವಿಲ್ ಲುಕ್ ಓವರ್ ದಟ್. ಓಕೆ, ಫಾರ್ ಟೈಮ್ ಬೀಯಿಂಗ್ ಒಂದೆರಡು ದಿವಸ ಆಗ್ಬೋದು. ಸೊ ಇವತ್ತು ನಾಳೆ. ಸೊ ಐ ವಿಲ್ ಜಸ್ಟ್ ಲುಕ್ ಓವರ್ ದಿಸ್ ಆ್ಯಂಡ್ ಐ ವಿಲ್ ಜಸ್ಟ್ ಸಾಲ್ವ್ ದಿಸ್ ಇಶ್ಯೂ. ಓಕೆ, ಸೊ ಐ ವಿಲ್ ನಾಟ್ ಮೇಕ್ ಯು ಟ್ರಬಲ್. ಸೊ ಥ್ಯಾಂಕ್ ಯು ಫಾರ್ ಯುವರ್ ವ್ಯಾಲ್ಯೂಬಲ್ ಫೀಡ್ಬ್ಯಾಕ್. ಓಕೆ, ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಸೊ ನೆಕ್ಸ್ಟ್ ಅದು ಬಿಟ್ಟರೆ ಮತ್ತೇನಾರು ಇದೆಯಾ? ಸೊ ಎನಿ ಡಿಸ್ಟರ್ಬೆನ್ಸು? ಇವಾಗ ಹೇಳ್ತಿರೋದು ಕಾನ್ಸೆಪ್ಟ್ಗಳು ಅರ್ಥ ಆಗುತ್ತಾ ನಾನು ಹೇಳ್ತಾ ಇರ್ಬೇಕಾರೆ? ಸೊ ಇಫ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಎನಿ ಡೌಟ್ ಅಟ್ ದಟ್ ಮೂಮೆಂಟ್ ಓನ್ಲಿ ಯು ಶುಡ್ ಆಸ್ಕ್.
ಇಲ್ಲ ಸರ್, ಮಿಕ್ಕಿದೆಲ್ಲ ಕರೆಕ್ಟಾಗೇ ಇದೆ.
ಅಲ್ಲ, ಎಲ್ಲರದು ಹೇಳಬೇಕು. ಸೊ ಗಿರಿಜಾ ಯು ಆರ್ ಸ್ಪೀಕಿಂಗ್. ಸೊ ಹೇಳ್ರಿ ಗಿರಿಜಾ ಅವರೇ.
ಅದೇ ಸರ್, ನಂಗೆ ಮ್ಯಾನ್ಯುಯಲ್ ಆಗಿ ಬರೀರಿ ಸರ್ ಎಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್ ಅಂತ. ಹಂಗೆ ಬರ್ಕೊಂಡು ಶೀಟ್ ಆಫ್ ಪೇಪರ್ ಮೇಲೆ ಬರಿಬೋದಲ್ಲ ಸರ್, ಲೈಕ್ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಇನ್ ನೋಟ್ ಪ್ಯಾಡ್?
ಅಲ್ಲಲ್ಲ, ನೋಟ್ ಪ್ಯಾಡು ಕಂಪ್ಯಾಟಿಬಲ್ ಇಲ್ಲ ಅದು. ಸೊ ನೋಡೋಣ, ಅದನ್ನು ನಾನು ಮಾಡ್ತೀನಿ. ಸೊ ಪೇಪರಲ್ಲಿ ಹೆಂಗೆ ಅಂತ ಇವಾಗ ಕೇಳ್ಕೊತೀನಿ. ಹೆಂಗಿದ್ರು ಸಂತೋಷ್ ಸರ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅಂತ ಹೇಳ್ತಿದ್ರಲ್ಲ. ಸೊ ಐ ವಿಲ್ ಜಸ್ಟ್ ಗೋ ಥ್ರೂ ದಟ್. ಯಾಕೆಂದರೆ ನೋಟ್ ಪ್ಯಾಡ್ ನಮ್ಮಲ್ಲಿ ಇನ್ಸ್ಟಾಲ್ ಆಗಿಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ಏನು ಮಾಡ್ಬೋದು ಅಂತ ನೋಡ್ತೀನಿ. ಸೊ ಆರ್ ಎಲ್ಸ್ ಐ ವಿಲ್ ಡಿಸ್ಪ್ಲೇ. ಸೊ ನಾನೇ ಬರೆದ್ಬಿಟ್ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಕೊತ ಬರೆದ್ಬಿಟ್ಟಿರೋ ಶೀಟ್ಸನ್ನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ. ಇಸ್ ಇಟ್ ಓಕೆ?
ಓಕೆ ಸರ್.
ಈಗ ನಾನೇ ಮುಂಚೆನೇ ಬರೆದಿರ್ತೀನಿ. ಸೊ ಐ ವಿಲ್ ಜಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ದ ಕಾನ್ಸೆಪ್ಟ್. ಐ ವಿಲ್ ಡಿಸ್ಪ್ಲೇ ಫಾರ್ ಯು ಪೀಪಲ್ ಆ್ಯಂಡ್ ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಈಚ್ ಆ್ಯಂಡ್ ಎವ್ರಿ ಕಾನ್ಸೆಪ್ಟ್ ಹೆಂಗೆ ಬಂತು ಅಂತ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ. ಓಕೆನಾ?
ಎಸ್ ಸರ್.
ಓಕೆ ಸರ್.
ಓಕೆ, ಅಪಾರ್ಟ್ ಫ್ರಮ್ ದಟ್, ಸೊ ಇವಾಗ ಫಸ್ಟ್ ಮಾಡ್ಯೂಲ್ ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ. ಸೊ ಯು ಹ್ಯಾವ್ ಸೀನ್. ಸೊ ನಾನು ನೋಟ್ಸನ್ನು ಡಿಸ್ಪ್ಲೇ ಹಾಕಿದ್ದೀನಿ, ಗ್ರೂಪಲ್ಲಿ ಹಾಕಿದ್ದೀನಿ. ಸೊ ಯು ಕ್ಯಾನ್ ಗೋ ಥ್ರೂ ಬಿಕಾಸ್ ಫಸ್ಟ್ ಮಾಡ್ಯೂಲ್ ಈಸಿ ಇದೆ. ಸೊ ಈಸಿ ಟು ಸ್ಕೋರ್ 20 marks. ಸೊ ಇಟ್ ಈಸ್ ನಾಟ್ ಡಿಫಿಕಲ್ಟ್ ಎಟ್ ಆಲ್. ಆ್ಯಸ್ ಪರ್ ಮೀ ಇಟ್ ಈಸ್ ನಾಟ್ ಡಿಫಿಕಲ್ಟ್. ನಿಮಗೇನಾರ ಡಿಫಿಕಲ್ಟ್ ಅಂತ ಅನಿಸ್ತಾ ಇದೆಯಾ?
ಅದು ನ್ಯೂಮರಿಕಲ್ಸ್ ಮಾತ್ರ ಸ್ವಲ್ಪ
ನ್ಯೂಮರಿಕಲ್ಸ್ ಬಿಟ್ಟಕ್ಕೆ. ನ್ಯೂಮರಿಕಲ್ಸ್ ಐ ವಿಲ್ ಸಾಲ್ವ್ ಯು. ಸೊ ನಾನು
ನ್ಯೂಮರಿಕಲ್ ಥಿಯರಿ ಮತ್ತು ಸರ್ಕ್ಯೂಟ್ಸ್ ಅದನ್ನ ಮ್ಯಾನೇಜ್ ಮಾಡ್ಕೊಳ್ಬಹುದು,
ಮ್ಯಾನೇಜ್ ಮಾಡ್ಕೊಬೋದು. ಆದರೆ ಮ್ಯಾನೇಜ್ ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕಿಂತ ಸೊ ಸರ್ಕ್ಯೂಟ್ಸನ್ನು ಬರೀಬೇಕಾದ್ರೆ ಯು ಶುಡ್ ಬಿ ಅವೇರ್ ಏನು ಯಾಕೆ ಬರೆದಿದ್ದಾರೆ ಅಂತ. ಸೊ ಅದು ಬಿಟ್ಟರೆ ಮತ್ತೇನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ ತಾನೆ. ಸೊ ಅದೇ ಏನು ಐ ಥಿಂಕ್ ಇಟ್ ಈಸ್ ನ್ಯೂಮರಿಕಲ್ಸ್ ಬಿಟ್ಟರೆ ಅದ್ರ ಬಗ್ಗೆ ತಲೆ ಕೆಡಿಸ್ಕೊಂಡ್ಬಿಟ್ರೆ ಐ ವಿಲ್ ಜಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಯು ಹೌ ದ ಕಾನ್ಸೆಪ್ಟ್. ಡೋಂಟ್ ವರಿ, ಟುಮಾರೋ ಕ್ಲಾಸಲ್ಲಿ ನಾನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ನ್ಯೂಮರಿಕಲ್ಸ್. ಓಕೆನಾ?
ಓಕೆ ಸರ್.
ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು. ಸೊ ಇಡಿ ಥರ ಏನು ಆಗ್ತಿದೆ? ಇಡಿನೂ ಹಿಂಗೆ ಆಗಿತ್ತಾ? ಸೊ ವೆದರ್ ಯು ಆರ್ ಫೀಲಿಂಗ್ ದ ಸೇಮ್ ಇನ್ ಇಡಿ ಸಬ್ಜೆಕ್ಟಲ್ಲಿ ಇದೇ ಥರ ಏನಾರು ಆಗಿತ್ತಾ?
ಇಲ್ಲ ಸರ್, ಇಡಿ
ಎಸ್ ಸರ್ ಅಂತ ಹೇಳ್ತಿದಾರಲ್ಲ, ಹೇಳ್ಬೇಕು. ಸಿ ವಾಟ್ ಈಸ್ ದಟ್ ಥಿಂಗ್ ಇಸ್ ಆನ್ಲೈನ್.
ಕೆಲವರಿಗೆ ಇರ್ಬೋದು ಸರ್, ಇನ್ನು ಕೆಲವರಿಗೆ ಇಡಿ ಏನಾಯ್ತಂದ್ರೆ ಎಷ್ಟೊಂದು ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಿತ್ತಲ್ಲ ಸರ್, ಮುಂಚೆ ಓದಿದ್ವಿ ಅದೇ ಸೇಮ್ ಬಂದಿತ್ತು.
ಬಟ್ ಅದೇ ಬಿಕಾಸ್ ಇಫ್ ಯು ಡೋಂಟ್ ಸ್ಪೀಕ್ ಈವನ್ ವೆನ್ ವಿ ಆರ್ ಟೀಚಿಂಗ್ ಇನ್ ದ ಕ್ಲಾಸ್, ನೋ ಬಡಿ ಎನಿ ಡೌಟ್ಸ್ ಇದೆಯಾ ಅಂದರೆ ಏನೂ ಹೇಳಲ್ಲ. ಸೊ ದಟ್ ಈಸ್ ವೇರ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಫಾಲ್. ಬಿಕಾಸ್ ಇವಾಗ ಒಂದು ಮಾಡ್ಯೂಲ್ ಆದಮೇಲೆ ಇವಾಗ ನೀವು ಹೇಳ್ತಾ ಇದ್ದೀರಿ ನ್ಯೂಮರಿಕಲ್, ಅವತ್ತಿನ ದಿವಸನೇ ನ್ಯೂಮರಿಕಲಲ್ಲಿ. ಸೊ ಇಫ್ ಯು ಸಿ ಸಮ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ವಿಲ್ ಡೆಫಿನೆಟ್ಲಿ ದೇ ವಿಲ್ ಫಾಲೋ ಬೈ ಟೇಕಿಂಗ್ ಬುಕ್ ಆ್ಯಂಡ್ ದೇ ವಿಲ್ ರೈಟ್. ಬಟ್ few students, they will just listen. So ಕೇಳ್ಕೊಂತ ಹೋದರೆ ಏನೂ ಬರಲ್ಲ. So obviously we have to learn because the subject is there. You have to write the offline exam. So offline exam ಬರೀಲೇಬೇಕು. So you should know. ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಫಸ್ಟ್ 15 minutes ಪ್ರೀವಿಯಸ್ ಡೇ ಏನು ಕ್ಲಾಸಲ್ಲಿ ಮಾಡಿದ್ದೀನಿ, ಸೊ ದ ಸೇಮ್ ಥಿಂಗ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ರಿಪೀಟ್. ಸೊ ಅದಕ್ಕೋಸ್ಕರನೇ ನಾನು ರಿಪೀಟ್ ಮಾಡ್ತೀನಿ, ಯಾಕೆಂದರೆ ಸೊ ಕೇಳಿದ್ರೆ ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ಗಳು ಅರ್ಥ ಆಗುತ್ತೆ ಅಂತ. ಓಕೆ, ಸೊ ವಿಲ್ ಜಸ್ಟ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ಟುಡೇಸ್. ಓಕೆ, ಅದ್ರ ಬಗ್ಗೆ ತಲೆ ಕೆಡ್ಸ್ಕೊಂಡ್ಬಿಟ್ರೆ ಪ್ರಾಬ್ಲಮ್ ಬಗ್ಗೆ. ಸೊ ದಟ್ ನ್ಯೂಮರಿಕಲ್ಸ್ ಐ ವಿಲ್ ಜಸ್ಟ್ ಗೋ ಥ್ರೂ ದಟ್ ಆ್ಯಂಡ್ ಐ ವಿಲ್ ಜಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಫಾರ್ ಯು. ಸೊ ಇಟ್ ಈಸ್ ನಾಟ್ ಅ ಡಿಫಿಕಲ್ಟ್ ಒನ್. So I will just explain you. So in order to analyze the performance, so shall I start now?
Yes sir.
Okay. So in the previous day, so I was just discussing about what are the performance of an amplifier. So in that performance of an amplifier, we are considering that so this is a general block diagram of an amplifier, and for this we are going to have an input signal source. So this input signal source can be an actual signal source, so generated from any input signal source, So it will be having a source resistance. So R signal is nothing but the source resistance of this voltage signal source. So this will be always added in series with that. So and it will be connected to the amplifier input. So this can be considered an actual signal source, or this can be considered an output of the previous preceding stage of an amplifier. So this is the current stage. So we have to remember that. When you are going to discuss about the amplifier, so you can discuss it like it is going to be the output of one stage of amplifier will be given as an input to the next stage, and the output of this amplifier will be given as an input for the next stage. So like that only, in order to achieve higher gain, so we are going to cascade more number of amplifiers. It is also called as a multi-stage amplifier. So this can be actual signal source, or it can be considered as an output of the output voltage of the another output signal from the preceding stage of an amplifier. That can be considered as an input, and it will be it might have given to the input to this current amplifier stage. So that is what the general block diagram of this amplifier. So it is going to be represented. And if we go in detail about the equivalent circuit of this corresponding, so if you are going to consider the equivalent circuit, so amplifier ಒಳಗಡೆ ಏನಿರುತ್ತೆ, so what are the amplifier circuit and what is there inside that, so that corresponding equivalent circuit has been represented over here. So this functional diagram has been removed, and in place of that we are going to write the voltage amplifier over here. So here voltage amplifier, why I am calling as voltage amplifier, because so voltage at the input and voltage at the output, so we are going to give the voltage amplification for this amplifier, because it is a MOSFET amplifier. So in this MOSFET, so the input will be normally the gate to source voltage will be given as input. So if you are going to consider any MOSFET amplifier, so for that input will be in terms of voltage, and you are going to get the output across the drain to source. So that if you see the gain, that means the ratio of output voltage to input voltage, that is the limit of gain. So that is the limit of voltage amplification. So here also we are going to consider the example for an voltage amplification in which so for any amplifier, so if you consider a MOSFET, so we can say that at the input, the current flowing across the gate terminal. Suppose you consider this functional diagram, and this functional diagram as a common source. So source is common anta ankoli. So this is a source terminal, and this is the remote gate terminal, and this is the remote drain terminal anta. So this is a functional diagram for a common source ankoli. So if the source is connected to ground, and if you are going to apply the voltage between the gate and source, that corresponding voltage can be considered as the input voltage. So understood. So this is nothing but the input voltage will be considered as the gate to source input voltage. And what will be the current that will be flowing across the gate? So gate current will be, obviously it will be 0. So obviously it will be 0. So only the drain current will be there. So apart from that, any other current, no current will be flowing inside the MOSFET. So at any of the terminals, you are not going to find any current flowing. So Ig will be equal to 0. That means in this case, if I am going to take example of a common source, so gate will be the current that will be flowing. So that gate current will be 0. So the gate current is 0 means you can assume that the resistance, input resistance will be of infinite resistance. So that is what you are going to consider in the case of common source. So input resistance, so will be having at the same time, so the voltage amplification, this is nothing but the output voltage. So this output voltage is dependent upon the input multiply with the gain. So that is AV naught. So here why we are discussing about AV naught, because so we are not considering the load resistance at all. So whatever the output voltage which you are going to get, so for an unloaded amplifier, so we are going to consider this amplifier block diagram. So with an unloaded, it means RL is equal to infinity. We are not going to consider this. So for an unloaded amplifier, the gain which you are going to get, that is nothing but the open circuit voltage gain. So that is represented by AV naught. So AV naught into VI is nothing but what? V naught. So that is nothing but the output voltage. So V naught will be equal to AV naught times of VI. So that is the output voltage. And for any amplifier, you will be having the amount of resistance, because the current is flowing across this one means. So finally, you will be having some finite amount of resistance that is going to have. So that is nothing but R naught. So that is nothing but R naught represented as a finite amount of resistance, through which you are going to find out the output current I naught. So this I naught current is going to get because of the amount of resistance, finite amount of resistance R naught. So usually we will be telling, so operational amplifier at 100. So ideal characteristics ಏನಂತ ಹೇಳ್ತೀವಿ? So input impedance, input resistance will be infinite, and output resistance is 0 output resistance. So ideal characteristics of operational amplifier. So here also we are going to get the same. So if it is a common source amplifier, I am just explaining with the example because you can understand if it is a common source, because in the next also you are going to study the common source itself. So input resistance, so since there is no current flowing across this one, so Rn will be equal to infinity. That means input resistance will be infinite, and the output resistance so will be considered as an neglecting. So you're going to consider the finite amount of resistance, but it will be always less when compared to the load resistance. So this is a load resistance which you're going to connect, so that you're going to get the final output over here. So if the load resistance is not there, then if you compare the load resistance value as well as the output resistance of the amplifier proper. So this is the amplifier output resistance. So this R0 will be very much smaller when compared to RL. So why it should be smaller? Because whatever the output voltage which you are going to get over here, AV0 times of VI, that is the output voltage, it should appear across RL. Because if the value of the resistance R0 is some finite resistance value, suppose if it is in terms of kilo ohms means, so what will happen? So here it is also the load resistance will also be in terms of kilo ohms. So if both the resistance are there, then obviously the output voltage will get divided across here. So if the output voltage gets divided across R0 as well as RL means, so the voltage drop across RL will be very much lesser. So actually whatever the output voltage which you have to get, so that will get divided across these two resistance means finally the output voltage will be very small value. So for that purpose what we should see, so the amplifier output resistance should have a zero resistance. For an ideal case, the output resistance should be zero, but in the practical circuits you are going to have a small resistance value. So that effectively all the output voltage, so why that is there, because effectively all the output should appear across load resistance without any loss of the signal. So significantly voltage divider loss will happen. So in order to avoid that voltage divider loss or significant voltage loss, so we have to consider think that the amplifier output resistance should be very small value in terms of ohms, so not in terms of kilo ohms. So in that case, all the output voltage will be appearing across the load resistance. Suppose if the load resistance is not there, then whatever the output voltage you are going to get, so with respect to output voltage to input voltage, that gain is called as the open circuit voltage gain, AV0. So if you are not considering the RL, so at the same time, so in order to find out what is the value of this RL, so how you are going to find the amplifier output resistance? So for the finding the amplifier output resistance, so input resistance is nothing but what? VI by II. So what is the current that is flowing and what is the input voltage you are going to apply, so that you are going to find out the input resistance Rn. So current is 0, so whatever the input voltage, anything divided by 0, what will be the input resistance? So it will be infinite. So like that one. So in the case of common source, I'm going to discuss. So I am going to tell that how to find the value of the Rin. So similarly, how to find out the R0. So in order to find out the output resistance R0, so what we are going to find? So we are going to make the signal source voltage to 0. So because here whatever the voltage it is going to get, so it is amplified output voltage you will be getting. So because of that, the current flowing is going to be maximum. So V is equal to IR. So V is equal to increasing, so you are going to get the maximum amplified output you will be getting. So because of that, so you will be getting the current also going to be getting as a amplified, so the current flowing is also going to maximum. So in that case you are not going to find the actual resistance value. So in order to find the actual output resistance, so we have to set the signal voltage to 0. So if I'm going to set the signal voltage to 0, so entire this thing, V signal will be equal to 0 means obviously the VI will also be equal to 0, and this AV0 times of VI, so this is also going to be 0. So that is the amplifier you will not going to get, and you are going to connect one voltage source or a current source over here, and then you are going to find out what is the voltage between them, and you are going to find out what is the current that is going to draw by this resistance, so that you are going to find out the resistance value R0. So R0 is given by Vx by Ix. So in that case you are going to find out the value of the amplifier output resistance R0. So this is the load resistance, that is the you are going to find. So in that case you are going to find out what is the value of the input resistance. So input resistance value will be calculated by Rn will be equal to what? So Vi by Ii. So this is the third circuit, equivalent circuit resistance amplifier functional diagram has been written for them. In order to find out the value for the R0, that is the output resistance of R0 we are going to find out. So finding the input resistance Rin is given by Vi by Ii. So Vi is nothing but the input voltage, and the current which is going to draw, so that is nothing but the current. So Vi by Ii, that gives the input resistance Rin. The same case if you are going to consider this as a BJT amplifier, common emitter anta ankonಡ್ರೆ, so base hatra current will be flowing. So that will be considered as the base current IB, and VBE will be the input voltage. So VBE by IB, so that gives the input resistance for a common emitter amplifier. So common source only, so it will be the current will be 0, so it will be input resistance will be infinite. So like that you have to analyze. So this amplifier is just a block diagram. You can consider it as a emitter, BJT or an MOSFET as an amplifier block diagram, general block diagram you can consider. So in which one of the terminal is connected to ground means you can consider 3 different configuration, and for this 3 different configuration, how much the input voltage, where you are going to apply, and what is the current that is flowing. From that you are going to find out the input resistance value Rin. And then what is the effective input voltage Vi you are going to find out. So for this Vi, so Vi is the input voltage that is going to be developed across the input resistance. So what is this Vi? So this is the effective input voltage. So whether this input voltage will be same as this, so we need to say. So if the resistance, signal source resistance which is being connected, that is the source signal resistance, if it is very small when comparable to that of the input resistance of the amplifier, then obviously all the signal voltage will be appearing across the input of the amplifier without any loss. So the same thing how I have explained in the previous of our output voltage to appear across the load resistance, the same way. So in order to apply all the signal voltage to appear across the Rin, so this signal source resistance must be very negligible. So if this is a small finite amount of R signal value is there, then obviously potential divider. So voltage will get divided across these two, and the effective input voltage will not be exactly same as that of V signal. So in order to find out this, so we are going to find out what? So Vi will be equal to what? V signal into Rin divided by R signal plus Rin. So you are going to get that same thing. So effective input voltage will be equal to V signal into Rin divided by Rin plus R signal. So Rin, if it is high when compared to R signal, so in the denominator term you can neglect this term, and you will be getting Vi will be equal to V signal. That means effective input voltage will be equal to that of the signal source voltage. Understood? So this is about the effective input voltage, how we are going to find out the input voltage. So now the second parameter, so which is nothing but open circuit voltage gain. So as I told, open circuit voltage gain, it is defined as what? AV0. So AV0 will be defined as what? So ratio of output voltage to input voltage when the RL is disconnected. So RL is equal to infinite, or when RL is not there, unloaded amplifier. Whenever the unloaded amplifier is there, then the gain which you are going to get is nothing but the open circuit voltage gain AV0. So this is how you are going to find the open circuit voltage gain. So having understanding about this, so we are going to start with the characteristics performance for the common source amplifier. So we are going to move to the common source amplifier configuration now, because we have seen the 3 different configuration. So in that first configuration which you are going to see and which you are going to study the performance of the amplifier is common source amplifier with source resistance and without source resistance, and you are going to find out all the analysis for what will be the input resistance, what will be the output resistance, what is the open circuit voltage gain, what is overall circuit voltage gain, and what is normal voltage gain. So AV, AV0 as well as GV. So AV is the circuit voltage gain, AV0 is open circuit voltage gain, GV is overall circuit voltage gain. Okay, so there is difference, and I have explained in the previous class as well. So if you are going to get, so without excluding RL, so whatever the gain you are going to get, that is nothing but a open circuit voltage gain. It is nothing but AV0. So if you are going to have AV, so AV means circuit voltage gain, circuit voltage gain. So V0 divided by Vi. So from this load resistance, across the load resistance, whatever the output voltage is there, that output voltage to input voltage, whatever it is there, then that is called as a circuit voltage gain. Suppose if I want to know what is the overall circuit voltage gain, so a V0 to V signal. So V0 to V signal, if you are going to find, then that is called as overall circuit voltage gain. So this is just a open circuit voltage gain, and this is just a circuit voltage gain AV, and this is entire thing if you are going to consider, so that is nothing but the overall circuit voltage gain. So that we are going to see over here. So common source amplifier, so as shown in figure 7.35a. So as shown in figure 7.3a, so common source antidange, first you should draw this circuit. So you should draw, So source should be connected to ground and gate to be given as input and drain should be connected as here, and common source without source resistance. So it is the analysis of the amplifier which you are going to do. So common source without source resistance. Okay, so source resistance means we are not going to connect the resistance across the source, and we are going to analyze the performance of this. So characterizing the performance of this common source. So that analysis is called as common source without source resistance. So for that common source, so source is common, gate as well as drain, and for this gate and source we are going to apply a signal source voltage. So as that is signal source voltage will be connected, small signal source voltage along with the source resistance will be added in series, and it will be connected to the gate to the terminal. So between the gate and source we are going to apply a signal source voltage. Across the drain resistance we are going to get the output. So that output is nothing but a output resistance or not, so, and that output is nothing but output voltage. So you're going to get the output voltage across here. So that is nothing but output voltage. So in order to find out the output resistance of the amplifier, this amplifier proper, so I have to connect this voltage between this terminal. So in order to find connect a output, I'm going to connect a test voltage circuit across here. That is given by Vx, and the current that will be flowing is nothing but Ix. So with that we are going to find what is the Vx by Ix, that is going to find out the value of the resistance R0. And we are not connected a load resistance, RL we have not connected, so that is unloaded. So this is nothing but unloaded, and here we are going to apply the input voltage. So here it will be having a current which will be flowing over here is 0, and also we can say that this is the input voltage, so Vi, which is nothing but between the gate and source, that is the input voltage Vi, and the current II and Vi is there. So here you are going to find out the input resistance Rin. So this is about the common source. So correspondingly, how you are going to write? So this place you are going to represent the equivalent circuit model. So this is nothing but amplifier. So this amplifier functional diagram. So as we have seen in the functional diagram in the previous, so this is a common source as an amplifier. We are going to consider this as a common source, and this functional diagram you are going to correspondingly equivalent circuit you are going to write over here. So corresponding equivalent circuit. So gate is there, source is there, drain is there. So that is how you are going to write. Here it is a gate, and here it is a source, and here it is a drain. So between the gate and source, what is there? So input voltage Vi is there. So here you are going to find out the input voltage that will be equal over here. So this is the input voltage. So that is the Vi, and from here we are going to find out the amplifier input resistance Rin. So here they have written Rin is equal to infinity. Why? Because so the current flowing inside the gate is 0. Ig will be equal to 0. So because that fundamentals we know that since the gate current flowing is 0, so in that scenario, so we can say we can write Rin will be equal to infinite. So directly we can write, because whatever the input voltage divided by the current 0, so you will be getting Rin is equal to infinity. That means the input resistance of this common source amplifier is infinite. And then, so what is the output? So output is nothing but what? So V0 will be equal to, so nothing but so in this common source you are going to see what is the output. So output is nothing but a controlled current source. So you are going to see this is the output, because you are going to have an input across here, and the current which will be flowing across here is nothing but the drain current. So ID. So ID is the current. So that will be equal to is a function of controlled voltage source. So Gm times of Vgs, that is the amount of current that is flowing from here, from drain to source, that is written over here, Gm times of Vgs. So here we are going to get the Vgs minus Vi. So since Vgs minus Vgs will be equal to Vi, so it is not minus, so Vgs will be equal to Vi. Why? Because since the input resistance is infinite, so there is no whatever the voltage signal V signal you are going to apply, so there is effectively all the voltage will be appearing across the Vi without any loss. So since there is no loss over here, so Vi can be equal to Vgs, because infinite input resistance is there. So there will be, since this value will be negligible when compared to that infinite resistance, so effectively all the voltage which you are going to apply, it is going to be applied across the gate and source. So we are going to write it as nothing but Vgs will be equal to Vi. So because Rin is equal to infinity, you are going to get Vgs will be equal to Vi. And then since Vgs is the input voltage, so control voltage source, so that is nothing but Gm into Vgs, that is the control current source, that is nothing but Gm times of Vgs you are going to get. and this is about the amplifier. So this is the amplifier functional diagram. So this is nothing but external resistance RD which has been connected over here. So through which we are going to get develop the output voltage. So we know, and then we can find out what is the function of the output resistance or not. So when we look across the output terminal without any load resistance, what is the output resistance? So here we have not considered we have neglected the channel length modulation. That means finite amount of resistance or not we have not considered here. So if we are going to consider the finite amount of resistance, then it will be a parallel of these two, that will be the equivalent resistance you will be getting. But here in this functional diagram we have neglected the channel length modulation. So for the neglecting of the channel length modulation, you are not going to have any finite amount of resistance between the drain and source. So drain and source madhyale R naught illa. So in that scenario, so if I find the output resistance, so output voltage we know that this is the output voltage we know, and current we know that Gm into Vgs, and from that we can see what is the value of the resistance R naught, RD. So RD is nothing but the output resistance. So we can easily determine R naught is nothing but the amplifier output resistance will be equal to RD. So that is same. Okay, that will be equal to RD itself. So we'll just see what are the parameters associated with that. Since we are going to write the corresponding equivalent circuit, and we have written without R naught. So the first common source amplifier circuit ತಗೊಂಡಿದ್ದೀನಿ. So this common source amplifier corresponding equivalent circuit ಬರೆದಿದ್ದೀನಿ. So this is nothing but a hybrid pi model they are going to get. So this is nothing but a hybrid pi model in the case. So this is the equivalent circuit model which you have written. So after writing the hybrid pi model, that is nothing but without finite amount of resistance R naught, that means neglecting the channel length modulation, so R naught, we can obtain the common source equivalent circuit. So, and then from that we have seen Rin is equal to infinity because Ig is equal to 0. In that case, the input voltage will be equal to the signal source voltage V signal, and then at that instant we can write Vgs will be equal to Vi. So Vgs will be equal to Vi, Vi will be equal to V signal. So I can write Vgs will be same as that of V signal. So input voltage will be same as that of the gate to source voltage, as that is will be equal to V signal. And what will be the output voltage? So output voltage will be equal to what? So output voltage will be equal to V is equal to IR, so ID into RD. So we know that we have seen in the previous expression when we are dealing with the small signal operation and model. So when we are discussing the small signal operation model voltage gain, when we are deriving the voltage gain expression, so V naught is this. So V naught is nothing but VDS. So in that case, VDS will be equal to what? Minus GM into RD into VGS. So from that we have studied, we have obtained the gain. So it is equal to minus GM times of RD. So now V naught is equal to what? The gain multiplied with the input. So V naught is the output voltage. So what is the gain for common source? Minus GM into RD is the common source gain. Multiply with VGS is nothing but the input voltage. So this gives the output voltage. So minus GM into VGS into RD. So minus GM into VGS, because 180 degree out of phase, because we have going to get the output across the drain. So it will be 180 degree out of phase. So minus GM into VGS into RD. So this is the RD resistance. So final output voltage will be equal to current multiplied with resistance. Okay. So this is the current. So control current. So GM into VGS into RD. That is gives the final value of the output voltage V naught. So that is nothing but the output voltage. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? Whether you are following? ಅರ್ಥ ಆಗ್ತಿದೆಯಾ ಅಂದ್ರು?
ಹೌದು ಸರ್, ಅರ್ಥ ಆಗ್ತದೆ.
Okay. So next is what? So input resistance ಕಂಡಿಡಿದಾಯಿತು. So what is the output voltage ಕಂಡಿಡಿದಾಯಿತು. So in that we have find out what is the gain expression as well already. So now the final parameter is we have to find out the output resistance. So output resistance ಕಂಡಿಡಿಬೇಕು. So with this I will just stop today's session, and I will just start with the tomorrow's session. So third and final parameter. So input resistance, output resistance, as well as the voltage gain is there. So voltage gain, so output voltage we have found out. So now we need to find out the output resistance of an amplifier. So our R naught. So R naught is nothing but equal to RD ಅಂತ ಹೇಳಿದೆ. So already I have told. So we are going to see how it is going to. So R naught is the resistance when we looking back in the output terminal. Output terminal ಇಂದ ನೋಡಿದಾಗ, so what is the resistance that is associated with the amplifier? That is nothing but output resistance R naught. So when we set Vi is equal to 0, so Vi is equal to 0, so that is the normal procedure. So in order to find out the output resistance for any amplifier, so set the signal voltage V signal equal to 0, so obviously Vi will be equal to 0. So obviously we are going to connect one test circuit voltage which is going to have a test voltage as Vx, and for which the current which is going to draw the current is nothing but Ix. So that is going to give as the that is going to give the value for the output resistance R0. So R0 is nothing but Vx divided by Ix. So this is the conception which I have given in the previous when we are going to categorizing the amplifier to find out the output resistance. So since the R0 is determined, so Vi is equal to 0. So Vi is 0 ಆಗ್ತಿದಂಗೆ what is the value? So R0 does not depend on R signal. So R signal ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಲ್ಲ. So because input signal voltage is 0 ಆಯಿತು ಅಂದರೆ signal source voltage or signal source resistance is also not going to depend, and then the control voltage source AV0 into Vi. So Vi is also equal to 0. So if I am going to say, so that is also going to be 0, and the output resistance R0. If I consider the output circuit equal, so you are going to have a Thevenin equivalent circuit of the amplifier output, and then if I connect an output voltage V0 can be found out by output voltage. So output voltage is nothing but AV0 into Vi. If I am going to have a load resistance is there, that voltage multiply with RL divided by total RL plus R0 is going to happen. If load resistance is not there, then obviously the output resistance is defined by RD itself. So if I'm going to find out the value of the R0, so if I want to find out the value of the R0, so at the output side, so all this signal voltage is going to set to 0, and then we can see, so signal set to voltage 0 ಆಯ್ತದಂಗೆ, so this is the output voltage which I am going to get. So this voltage multiplied with the RD, that gives the value of the, this is the, when you look from the output voltage, so from the output section, so this is the only the final output voltage you are going to get. So that is the RD. So that is the drain resistance RD. So finally I can write simply R0 can be equal to RD. But if I am going to have a load resistance connected over here, so if I am going to have a load resistance RL which is going to connect externally means, so output voltage will be obviously across the load resistance as well as, so that this will have a parallel combination, and the equivalent circuit equivalent resistance value will be the output resistance. So RD parallel RL will be the output resistance. So the output voltage will be having this value. So output voltage will be equal to, so this is the output voltage, so AV0 into Vi. So AV0 is nothing but unloaded output voltage. So that is the AV0 into Vi is nothing but unloaded output voltage. So AV0 means what? So without RL, so what is the gain you are going to get? So gain multiplied with input voltage is nothing but the output voltage for an unloaded. So if that is multiplied with RL, so divided by total resistance RL plus R0, that gives the final total output voltage V0. So this is about the how we are going to find if the RL, so load resistance is present. So with this I will just conclude today's session. Okay, so if you are having any doubts, so I will just make sure that as you have given input, so I will just go through that one, and I will solve tomorrow. After completing this topic, I will just solve that numericals. Okay. Okay. So
Okay, sir.
Okay, I'll just conclude today's session. Okay, bye. So only 35 members are there out of 57. So kindly make sure this is attendance is compulsory. And as I'm telling, so this is attendance is compulsory.